Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at applications of parabolas. So basically what we're looking at is maximum or minimum values of a quadratic equation. So we know that quadratic equations or parabolas always have either a minimum value if it goes like that, or a maximum value if it goes like that. And that's what we're going to find out. So remember, the maximum or minimum value, whichever it is, occurs always at the turning point. So all of this will involve finding the turning point. Now, it can be a bit difficult to find the turning point using completing the square, which is what we've been doing. Another way you can find the turning point, if you have ax squared plus bx plus c, it turns out that the turning point always occurs at x equals minus b over 2a. So I'll show you both methods for that. Let's look at an example. So a rocket is fired from the ground. Its height in meters above ground after x seconds is given by this. Calculate the maximum height of the rocket. So basically we want to find the maximum value of this function. We want to find the turning point of this parabola. So there are two ways that we can do it. We can use completing the square or this formula here. So what if I wanted to complete the square? Well, what I have here is y equals negative 10x squared plus 50x. When you want to complete the square, if there's a number in front of x squared, you have to take it out. So I get negative 10x squared. What do I times by negative 10 to get negative 50x? Well, that's negative 5x. So if I wanted to complete the square, I'd have to do it on. So what we would then do is we would write this as x minus 2.5 squared. Why did I pick 2.5 out of all possible values? Because negative 2.5 is half of 5. So what goes outside here? Well, there wasn't anything to begin with, so it's like a 0. It'll be 0 minus 2.5 squared. So that is, we'd have minus 6.25. So then we expand to fully put it in completing the square form. So it'll be negative 10 x minus 2.5 squared. And then negative 10 times negative 6.25 is positive 62.5. And putting it in this form gives us our answer. The turning point of this parabola, which is the same as this parabola, it would be 2.5, 62.5. Now we know that this is going to be a maximum because this parabola would be a frowny face because the coefficient of x squared is negative. So what that means is the maximum height was y, remember, is going to be 62.5 meters, and it'll occur when x is 2.5, after 2.5 seconds. So there's a lot of work in that, but there is an easy way. The easier way, as I said before, is that the turning point always occurs at x equals minus b over 2a. So here we have b and a. So x, the x value of the turning point is minus b over 2 times a. So you put that in your calculator, you get 2.5 like we did over here. Then you can just substitute that into the original equation. So y would be 50 times x minus 10 by x squared. Remember to put it in brackets. And if you put that in your calculator, you actually get the same answer, 62.5. So either way, we found that the maximum height 62.5 meters after 2.5 seconds. This way is probably a lot easier than that way. All right, let's look at another example. So 100 meters of fencing is used for 3 sides of a paddock. Calculate the maximum possible area that it could enclose. This one's a bit difficult because we need to come up with the quadratic equation, whereas in the previous example, it was given to us. So here we have 3 sides of a paddock adding up to 100 meters. The 4th side's water or something. It's not getting fenced. So what we do is we're going to call the width here x. So what will this side be in terms of x? Well, if we just call it y for now, we know that x plus y has to equal 100. So what we're going to do is get y in terms of x. The reason is we don't know how to solve quadratic equations that have x's and y's. We only want a quadratic equation with x's. So we want to get y by itself in terms of x. So we can just subtract 2x from both sides. So this side here, we're going to update it. It will be 100 minus 2x. Basically, this side here is just 100 minus that side minus that side. So now we can come up with an expression for the area. The area is just going to be length and width multiplied together. So expanding that gives us 100x minus 2x squared. So we want the maximum possible area. This will have a maximum, because if I think about this as a parabola, the coefficient of x squared is negative, so it will be a frowny face. It will have one maximum y value, and that's what we want to find. Now, we could complete the square here and find the turning point, but it's probably easiest just to use the turning point occurs at x equals minus b over 2a. So it occurs at minus b is 100. B is always the coefficient of x over 2 times a. So if you put that on your calculator, you get 25. That's saying the maximum area it could enclose means that this will be 25, this will be 25. So this will be 100 minus 25 minus 25, it will be 50. So the maximum possible area it could enclose is 50 times 25, which will give 1250, and because it was 100 meters, this will be in meters squared. So again, we could have taken our function here, we could have used completing the square to find the turning point. We would have found that the turning point of this function is 25, 1250. But I think it's much easier in max min problems to just use x equals minus b over 2a and then substitute that in. If we substituted x equals 25 into here, we would get 1250. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.